You ever see a drone just slice through the air and think to yourself, how in the world is it doing that? I mean, how does this little machine just hang there, totally weightless, almost defying gravity with such insane precision? It really does look impossible.
And it's true. They really do. 1 second they're hovering in place, perfectly still, like they're pinned to a spot in the sky. The next, poof, they can zip off in any direction. Up, down, sideways, or even pull off a perfect flip in midair. It's wild.
That's the real mystery, isn't it? It just feels like it shouldn't work based on everything we know about physics. Well, that's exactly what we're going to do in this explainer. We're pulling back the curtain on that magic to break down the surprisingly simple science that makes it all happen.
Okay, so let's dive right in. The answer to how these things fly, well, it all starts with their most basic design. This is our first, and honestly, our most important clue. So almost every drone you see out there is technically what's called a quadcopter. And like the name suggests, quad means 4. And those 4 propellers, they are the key to absolutely everything. Every bit of lift, every single movement, every stable hover, it all starts with those 4 blades. All right, so we've got our 4 propellers, but how do a few spinning pieces of plastic actually get a whole machine to lift off the ground and just laugh in the face of gravity? Well, to get that, we need to take a quick trip back to one of the most fundamental laws of physics. You've definitely heard this one before, probably in science class, but it is the absolute bedrock of how a drone flies. For every action, there is an equal and opposite reaction. It's simple, it's elegant, and it's the one single principle that gets a drone airborne. Let's just break this down real quick. Think of the propellers like super powerful fans. See, their blades are angled, so when they spin, they shove a ton of air straight down. That's the action. And then, good old Sir Isaac Newton kicks in, and the air pushes back with the exact same force, but in the opposite direction. That's the reaction, and it's what shoves the drone straight up. And boom, just like that, you've got lift.
Okay, so we're off the ground. Problem solved, right? Not quite. See, if all 4 of those propellers were just spinning in the same direction, the drone's body would start spinning like crazy in the opposite direction. It would be totally out of control. So getting into the air is one thing. But staying stable? That's the real art form.
And this right here is the incredibly clever solution. It's a brilliant piece of engineering, really. Instead of having all the propellers spin the same way, they're set up in pairs that spin in opposite directions. So you'll have 2 of them, usually diagonal from each other, spinning clockwise, and the other 2 spinning counterclockwise. And here's the beautiful result of that. The turning force from the clockwise propellers is perfectly, and I mean perfectly, canceled out by the force from the counterclockwise ones. It's like a constant, balanced tug of war that ends in a perfect tie. And that's what creates the stable, non-spinning platform that you need for controlled flight. All right, let's get to the final piece of the puzzle. We've got lift to get off the ground, and we've got stability to keep it from spinning out of control. But how does this stable machine pull off that magic trick of moving so smoothly? Well, this is where the brains of the operation come into play. Let's start with the basics, just hovering perfectly still. To do this, the drone's little computer brain makes sure all 4 propellers are spinning at the exact same constant speed. The upward push from the propellers perfectly matches the downward pull of gravity. The result? It just hangs there, perfectly balanced. So what if you want to move? It's actually pretty simple. You just mess with that perfect balance a little bit. To fly forward, the computer tells the 2 back propellers to spin just a tiny bit faster. That extra lift in the back tilts the whole drone forward. Now, some of that powerful upward thrust is angled, pushing the drone forward. And it's the exact same idea for moving in any direction. Now that sounds simple enough, right? But think about it. In the real world, the tiniest gust of wind or the slightest shift in weight should send it tumbling out of the air. So how does it manage all these tilts and corrections so perfectly, so fast, that it looks like it's just gliding on invisible rails? Okay, get ready for this, because this is the truly mind-blowing part. The drone isn't just making a few adjustments here and there. Its tiny little onboard computer is making over 400 corrections to the speed of its motors every single second. It's just this constant high-speed blur of tiny adjustments. So this is how the whole picture comes together. You've got the basic physics, Newton's third law, giving it the raw power to get off the ground. Then you have these tiny sensors, gyroscopes and accelerometers, that are constantly feeling every single little tilt and wobble. And finally, you have the powerful flight controller, the brain, that's processing all that information and making hundreds of those real-time adjustments every single second. So here's the most amazing takeaway from all of this.
That graceful, smooth, stable flight that you see, it's actually an illusion. The drone is in a constant state of falling and catching itself, over and over and over. It's a high-speed symphony of tiny corrections happening so fast that, to our eyes, it just looks perfect.
So the next time you see a drone just hanging effortlessly in the sky, you'll know it's not actually magic. It's this incredible partnership between pure physics, super-sensitive sensors, and lightning-fast computing. And that really just leaves us with one last thing to think about.